Hi friends, welcome to all. In this video, we are going to discuss CCNA version 7 lab activity, configure router on a stick inter VLAN routing. Before coming to this activity, friends, if you like to get any CCNA project support or CCNA online classes, you can contact our team using our website. Link you will get from the description below. And also, if you like to get this type of technical videos in future, consider subscribing. Also, don't forget to enable that bell icon near to the subscribe button so that you will get notification message whenever we upload a new video. Now back to our lab activity. Here we can see the topology what we have to design in our packet tracer. Also here we can see our addressing table, also VLAN table. We will go through the objectives. In part 1, build the network and configure basic device settings. Then in part 2, create VLANs and assign switch ports. Then in part 3, configure an 802.1q trunk between the switches. Then in part 4, configure inter-VLAN routing on the router. Then part 5, verify inter-VLAN routing is working. We will go through the background. Modern switches use virtual local area networks, that is VLANs, to provide segmentation services traditionally provided by routers in LAN configurations. VLANs address scalability, security, and network management. In general, VLANs make it easier to design a network to support the goals of an organization. Communication between VLANs requires a device operating at layer 3 of the OSI model. Routers in VLAN topologies provide additional security and traffic flow management. VLAN trunks are used to span VLANs across multiple devices. Trunks allow the traffic from multiple VLANs to travel over a single link while keeping the VLAN identification and segmentation intact. A particular kind of inter-VLAN routing called a router on a stick use a trunk from the router to the switch to enable all VLANs to pass to the router. In this lab, we will create VLANs on both switches in the topology, assign VLANs to switch access ports, verify that VLANs are working as expected, create VLAN trunks between the two switches and between S1 and R1, and configure inter-VLAN routing on R1 to allow hosts in different VLANs to communicate regardless of which subnet the host resides. They given a note here. The routers used with CCNA hands-on labs are Cisco 4221 with Cisco iOS XE release 16.9.4. The switches used in the labs are Cisco Catalyst 2960 with the Cisco iOS release 15.2. Other routers, switches, and Cisco iOS versions can be used. Depending on the model and Cisco iOS version, the commands available and the output produced might vary from what is shown in the lab. Refer to the router interface summary table at the end of the lab for the correct interface identifiers. Okay, we will use these models, and we have these models in our Cisco packet tracer simulation. So again, a note. Ensure that the routers and switches have been erased and have no startup configurations. If you are unsure, contact your instructor. Yes, if you do with the real routers and switches, we have to erase these startup configurations. Here they given the required resources. One router, a Cisco 4221 with a Cisco iOS XE release 16.9.4. Then two switches, Cisco 2960 series, two PCs, console cables. Then to configure the Cisco iOS device via the console ports. Then Ethernet cables as shown in the topology. Okay, we need all these resources except these console cables because we are going to do in Cisco packet tracer simulator. Coming to the instructions, in part 1, build the network and configure basic device settings. In part 1, you will set up the network topology and configure basic settings on the PC host and switches. In step 1, cable the network as shown in the topology. Attach the devices as shown in the topology diagram and a cable as necessary. So here we can see our topology. We will design this topology in Cisco packet tracer. Here network devices, routers. So here we can see, here we don't have 4221, so instead we will use this 4331. Then two switches, we will use a 2960 series. Click on switches, and here we can see 2960. You will have two switches. Then two PCs. Here we have NT devices, and here we can see PC. Now we will rename these devices. It's R1, this is S1, and here is S2. Here is a PC-A, and here we have PC-B. Now coming to the connectivity, we will choose connections and copper straight through. We'll press Ctrl and we will click on copper straight through so that we can connect all these devices. Press Ctrl, then click on this copper straight through cable. Now click on R1 and we will select gigabit Ethernet 0/0/1. Then connect to S1, and here the port is FA0/5. Then again from S1, FA0/1 to S2, FA0/1. Now we will connect these PCs from S1 FA0/6 to this PC-A, from S2 FA0/18 to this PC-B. Now we can press escape so that we can release these connections. Okay. You will see what is next. Now in step 2, configure basic settings for the router. Console into the router and enable privileged exit mode. Then enter configuration mode. Assign a device name to the router. Okay, we will do that. We will click on R1. We will go to CLI, and here we will give no. Enable, configure terminal. We will set the host name as R1. Next is a disable DNS lookup to prevent the router from attempting to translate incorrectly entered commands as through their host names. Okay, we can do that. Here we will give no IP domain lookup and press enter. Next is assign class as the privileged exec encrypted password. That means we have to enable secret as class. We can do that. Enable secret as class. Next is assign Cisco as the console password and enable login. Also we have to give this the same password Cisco as the VTY password and enable login. We will do that coming to R1. First of all, we will go to line console 0. Then we will set the password as Cisco. Then we will login. Now we will exit and then we will go to line VTY. We will give for all the lines, that means from 0 to 15, total 16 lines. We will set the password as Cisco, then login. Then encrypt the plain text passwords. Yes, we have the command. We will exit from this line mode and here we will give service password encryption. Then create a banner that warns anyone accessing the device that unauthorized access is prohibited. Okay, we will create this banner. It's a banner MOTD, that is message of the day. We will start with the delimiter. Then we will give the message unauthorized access is strictly prohibited. Now save the running configuration to the startup configuration file. Okay, we can do that. Exit from here and then give copy running config startup config. So destination file name, we will give this default name, that is startup-config. Just press enter. Then set the clock on the router. Okay, we can do that. Use the question mark to help with the correct sequence of parameters needed to execute this command. We will do that. We will give a clock, then a set. Then we have to set this current time using this format. It's 10 minutes. We will give 30, then seconds. Okay. Then we have to give the day of the month. It's 13. Then we have to give month of the year. It's May. Then we have to give its year. It's 2020. Then press enter. Coming to step 3. Configure basic settings for each switch. Console into the switch and enable privileged exit mode, then enter configuration mode, then assign a device name to the switch. Okay, we will do that on both switches. First of all, we will go to S1 CLI, then press enter. Enable configure terminal, we can give in short CONF space T, then the host name as S1. Now we will go to S2 CLI. Enable, we can give short as EN conf T, then the host name as S2. Then disable DNS Lookup to prevent the router from attempting to translate incorrectly entered commands as though they were host names. Okay, we can do that. Here we have to give the command no IP domain lookup. Now we will go to S1 and we will do it. No IP domain lookup. Then assign class as the privileged exec encrypted password. We can do that. Here on S1, we will give enable secret as class. We'll close and then we will go to S2. Enable secret as class. Then assign Cisco as the console password and enable login. Also, we have to give a Cisco as the VTY password and enable login. We will do that. Coming to S2, we will go to line console 0. We will set the password as Cisco. Sorry, it's password as Cisco. Now it's correct. Then we will give the login command. Exit, then go to line VTY, all the lines from 0 to 15. We will set the password as Cisco. Then we will give login command. Then coming to S1, line console 0, password Cisco, login, exit. Then we will go to line VTY, all the 16 lines from 0 to 15, password Cisco, then login. Next is encrypt the plaintext passwords. We can do that. Now we are in S1. We will exit from this line mode and here we will give a service password encryption. We can give PASS, then we can press tab and here we can see password dash encryption, then press enter. Now we will go to S2. We will exit from this line mode, then give SER tab, then password PASS tab, press enter. Then create a banner that warns anyone accessing the device that unauthorized access is prohibited. Okay, we will do that. We will go to S1 and set banner MOTD. We will give unauthorized access is strictly prohibited. Just I will copy this command, this message. Then here press enter. Now we will go to S2. It's banner MO td, then the message. It's here, we already copied that. Then set the clock on both switches. Use the question mark to help with the correct sequence of parameters needed to execute this command. Okay, we can do that. First of all, we will do it on S1. We will exit from this mode, and here we will give it's a clock set. Then we have to set the current time in this format. It's 10 minutes, it's 48, then seconds. Then we have to give the day of the month, it's 13. Then the month, it's May. Then the year, 2020. Now we will do it on S2. CLI, we will exit from this mode. Then here we can give a clock set. Then the current time, 10, 48, we'll give 49. Then seconds. Then a day of the month, it's 13. Month is May. Year is 2020. Then copy the running configuration to the startup configuration on both switches. Coming to S1, here we will give that. We can give in short, it's copy running r space st, then press enter. So destination file name, the default file name startup-config. Okay, just press enter. Now we will go to S2 and copy r space st. Press enter. Now in step 4, configure PC host. Refer to the addressing table for PC host address information. So coming to our addressing table, here we can see PC-A IP address. Just I will copy this address. Then coming to PC-A desktop IP configuration, here we will give that IP address. Then here we can see it's a subnet to mask. Then we have to set its a default gateway. It's a 3.1. Oh, it's here. Default gateway. Now here we can see the IP address for PC-B. Just we will copy that address. It's a 4.3. And here we can see it's a subnet to mask and it's a default gateway. Coming to PC-B desktop IP configuration, here subnet to mask, then default gateway 4.1. Now we will move to part 2, create VLANs and assign switch ports. In part 2, we will create VLANs as specified in the table above on both switches. We will then assign the VLANs to the appropriate interface. The show VLAN command is used to verify your configuration settings. Then complete the following task on each switch. So in step 1, we have to create VLANs on both switches. So firstly, create and name the required VLANs on each switch from the table above. So coming to our VLAN table, here we can see we have to create these VLANs, VLAN 3, 4, 7, 8 with these names. We will create in S1, click on S1, conf space T, we will create a VLAN 3, then we have to give the name as a management. Next is VLAN 4, name is operations. Next is VLAN 7, name is parking lot. Next is VLAN 8, name is native. Now we will go to S2, CLI, configure terminal, VLAN 3, name is management. Next is VLAN 4, name is operations. Next is VLAN 7, name is parking lot. Next is VLAN 8, name is native. Then configure the management interface and default gateway on each switch using the IP address information in the addressing table. Okay, coming to our addressing table, here we can see the address for the device S1 and S2. And here we can see we have to assign this IP address for the interface VLAN 3, and we created VLAN 3 for management. Then we can see it's to mask and it's a default gateway. First of all, we will copy this IP address, I mean the IP address of device S1, 192.168.3.11. Then coming to S1 CLI, we will exit from this VLAN mode. Then we will go to the interface VLAN 3. Then we will set the IP address. It's here. Then it's a subnet mask. Now we will exit and then we will set its IP default gateway. It's a 3.1. Now we will go to S2 CLI. We will exit from this VLAN mode. Then we will go to the interface VLAN 3. Then we will set its IP address. It's 3.12. Then it's subnet to mask. Exit. Then we will set IP default gateway. It's a 3.1. Then assign all unused ports on both switches to the parking lot VLAN. Configure them for static access mode and administratively deactivate them. They given a note, the interface or range command is helpful to accomplish this task with as few commands as necessary. Okay, we can do that. Coming to our topology, here we can see on S1 we used FA0/1, FA0/5 and FA0/6. We will shut down all the ports except these 3 ports. Also, we have to assign these ports to parking lot VLAN, and then we have to configure static access mode. So we will do that. We'll click on S1. So we will go to all those interfaces. Interface as a range. It's FA0/1 we already used. So we'll start from 2 till 4 because 5 and 6 we used. Then we will give comma FA0/7 till 24. Also we have 2 gigabit Ethernet ports, G0/1 and 2. Okay, here we will give a switch port mode as access, then switch port access VLAN, it's I think 7. We'll verify that. Parking lot, here we can see it's 7. Okay, now we will shut down all these ports. Shut down. Same way we have to do it on S2. We'll go to S2 CLI, then interface as a range FA. We will start from 0/2. Before that, coming to a topology, here we can see we used FA0/1 and FA0/18. Then we will shut down all the ports except these 2. Okay, back to S2. FA0/2 till 17 because 18 used. Then again FA0/19 till 24. Also we have a 2 gigabit Ethernet ports, G0/1-2. Okay, somewhere we made a mistake. We will see that we have to put a comma here, then press enter. Now it's correct. We will give a switch port mode as access, then a switch port access a VLAN 7, then shutdown. Now in step 2, assign VLANs to the correct switch interfaces. Assign used ports to the appropriate VLAN specified in the VLAN table above and configure them for a static access mode. Be sure to do this on both switches. Coming to this VLAN table, here we can see in this switch, port FS0/6 should be assigned to VLAN 3. Then switch S2, port FS0/18 should be assigned to VLAN 4. Yep, we can do that. So we will go to S1. Then exit from this range of interfaces. Then we will go to the interface fast Ethernet. I think it's a 0/6, correct? FA0/6. Then we will give a switch port mode as access. Then we will give a switch port access. We have to give to VLAN 3. Press enter. Now we will go to S2. Exit from these interfaces. Then go to interface FA0/18. Switch port mode as access. Switch port access VLAN, it's 4. Press enter. Then issue the show VLAN brief command and verify that the VLANs are assigned to the correct interfaces. Okay, we'll go to S1. We'll press Ctrl Z, then press enter. Here we will give a show VLAN brief. And here we can see the details. We will expand it so that we can see fully. Okay, here we can see port FA0/6 is assigned to VLAN 3, and here we can see all the unused ports are assigned to parking lot, that is VLAN 7. And here we can see these two ports, that is FA0/1 and FA0/5. They are in default to VLAN 1 because we have to convert these ports to a trunk. Now we will go to S2 CLI, press Ctrl Z and press enter. Here we will give a show VLAN brief, and here we will verify the configuration. Here we can see all unused ports are assigned to parking lot, that is VLAN 7, and the port FA0/18 is assigned to VLAN 4, and we have FA0/1 which is in default to VLAN 1 because we have to make this port as trunking. Coming to part 3, configure an 802.1q trunk between the switches. In part 3, we will manually configure interface FA0/1 as a trunk. Coming to step 1, manually configure trunk interface FA0/1. Change the switch port on interface FA0/1 to force trunking. Make sure to do this on both switches. We will do that. First of all, we will go to S1. Then we have to go to that interface, configure terminal interface FA0/1. Then we will give a switch port mode as a trunk. Now we will go to S2. We have to manually give a trunk. Configure a terminal interface FA0/1. Switch port mode as a trunk. Then, as a part of the trunk configuration, set the native VLAN to 8 on both switches. You may see error messages temporarily while the two interfaces are configured for different native VLANs. Yes, that's correct, because both sides we have to configure the same VLAN. I mean the native VLAN. So we will do that configuration. First of all, we will do it on S1, and now we are in this FA0/1. Here we will give a switch port trunk native VLAN 8. Now we will go to S2, and here we can see that message, inconsistent local VLAN. Okay, here also we will set that to VLAN, native VLAN. Switch port. Oh, again we get that message, mismatch discovered on FA0/1 with S1 FA0/1. Okay, we have to set 8 native VLAN. That can be done. Switch port. It's a trunk native VLAN. Sorry, it's a VLAN 8. Now here we get the message unblocking fast Ethernet 0/1 on this VLAN port consistency restored. Good. Then as another part of trunk configuration, specify that VLANs 3, 4 and 8 are only allowed to cross the trunk. Okay, that can be done. Here we will give a command do show. We will give interface trunk, and here we can verify VLANs allowed. It's allow 1, 3, 4, 7 and 8. But here, as per the instruction, we have to allow only 3, 4 and 8. We have to remove this 1 and 7. Okay, we can do that. We will give the command here, switch port trunk, and here we have allowed. Then we can remove, allowed VLAN. Then we will give remove. We will remove 1 first. Then we can remove 7. Press up arrow, then give 7. Just we will verify that. Press Ctrl Z, press enter. Show interface trunk. Now here we can see VLANs allowed and active in management domain only 3, 4 and 8. And we can see native VLAN is 8. Its status trunking, and here we can see the port is FA0/1, mode is on. In the same way we will do it on S1. Okay, and here we will give its switch port trunk allowed VLAN. We can remove 1. Also we will remove 7. Press Ctrl Z, then verify it. Show interfaces trunk. Here we can see the port is FA0/1, mode is on, manually configured trunk, status trunking, native VLAN 8, and here we can see VLANs allowed and active in management domain 3, 4 and 8. Then issue the show interfaces trunk command to verify trunking ports, the native VLAN and allowed VLANs across the trunk. Yes, we given this show command on both switches and we verified all these. Now in step 2, manually configure S1's trunk interface FA0/5. So configure the FA0/5 on S1 with the same trunk parameters as FA0/1. This is the trunk to the router. So here we can see that interface FA0/5 in this switch S1. We will do that coming to S1, CLI. Okay, password Cisco, enable password class, configure terminal. Then here we will go to that interface, that is FA0/5. Then we will give a switch port mode as access, so it's trunk. Yes. Then save the running configuration to the startup configuration file on S1 and S2. Okay, we will do it on S1. We will give the command end here, press enter again, and we will give copy running config startup config. So it's running dash config space startup dash config. So here we can see destination file name startup config. Okay, just press enter. Same command we will give on S2 CLI. Password is Cisco. Enable password is class. Here we can give in short COP space R space ST. Then we can press enter. This is copy running config startup config. Press enter again. Then issue the show interfaces trunk command to verify trunking. Why does FA0/5 not appear in the list of trunks? Okay, we will verify that. We will click on S1, then we will give that command show interface trunk, and here we can see only one port, that is FA0/1, and we cannot see this port FA0/5. Why it is not showing this port FA0/5 here? Because coming to our topology, we can see this link is down. That means the interface gigabit ethernet 0/0/1 in this router R1 is administratively down. Hence here we have to bring this interface up so that we can see this interface FA0/5 will be in trunking. Okay, now we will go to part 4. Configure inter-VLAN routing on the router. Activate interface G0/0/1 on the router. Right, now we are going to activate this interface in this router R1. Coming to R1 CLI. Password is Cisco. Enable password is class. So configure terminal, we have to go to that interface, that is G0/0/1. Then we have to give no shutdown command, then press enter. Now here we can see the link between this router R1 and S1 is up. Now we can verify the trunk in this S1. We will give the command show interfaces trunk, and here we can see the port FA0/5 mode is on and status trunking. Then configure sub-interfaces for each VLAN as specified in the IP addressing table. All sub-interfaces use 802.1q encapsulation. Ensure the sub-interface for the native VLAN does not have an IP address assigned. Include a description for each sub-interface. Okay, we will create these sub-interfaces for the VLAN in this router R1. Coming to R1, we will exit from this interface. This is the physical interface. Then we will go to the interface gigabit ethernet 0/0/1. We will create for 3. So VLAN 3. We will give 1.3. Okay. Then we will give a description for this. Description. You can press a tab so that it will complete this incomplete unique command. Description, we will give management network. Okay, also we have to give encapsulation .1q and VLAN ID, it's for VLAN 3. Also we have to set its IP address 192.168.3.1. Then we have to give it a subnet to mask. Now we will create the next sub interface. We will exit from this interface. Then we will give an interface G0/0/1.4 and press enter. Then we will give the description. It's a operations network. Also we will give encapsulation dot 1q, VLAN ID is VLAN 4. Then we will set the IP address 192.168.4.1. Then it's to mask. Now, no need to create a subinterface for the VLAN 7, that is parking lot, because all unused ports we assign to that VLAN 7. Then we will create for VLAN 8. Exit. Then go to the interface G0/0/1.8. Okay. Then we will give its description. We will give the description as a native VLAN. Also, we have to encapsulate .1q. VLAN ID is 8 and this is for native. So put a question mark and here we can see. Okay, it's encapsulation native. Here we can see the command. So we can complete it, encapsulation .1q native, then press enter. As per the requirements for this subinterface, we are not going to create an IP address. Okay, use the show IP interface brief command to verify the subinterfaces are operational. We will verify that. Here we will give the command end show IP interface brief, and here we can see all the subinterfaces we created. .1.3 its IP address, status and protocol up. .4 and .8, and for .8 we did not assign any IP address, and we can see its status and protocol up. Now coming to part 5, verify inter-VLAN routing is working. Step 1, complete the following test from PC-A. All should be successful. You may have to disable the PC firewall for pings to be successful. Yes, so if you are using the real systems, we have to disable a PC's firewall. Anyways, here we are using packet tracer, so no need to worry about the firewall. Ping from PC-A to its default gateway. Okay, we will do that. We will ping from PC-A to its default gateway. Its default gateway is 192.168.3.1. This PC is assigned to VLAN 3. Even we can verify that. Its default gateway address using IP config space/all. And here we can see its IP address details. Here we can see default gateway address. We will copy that. Then we will ping to this default gateway. Ping to this default gateway. And here we can see we get the replies. Then ping from PC-A to PC-B. Okay, we will get the IP address of PC-B. It's 4.3. Then coming to PC-A. Ping to PC-B. And we are waiting for the replies. Request timed out and it's working. We get the replies. Once more we can try it. Just press up arrow. So we will get the previous command. Ping to PC-B, then press enter. And here we can see it's working. We get the replies. Packet to send for, received for, lost 0. Then ping from PC-A to S2. Okay, we will do that. Coming to PC-A. Here we are going to ping to 192.168.3.11. This is the IP address of switch S2, and we are waiting. Yeah, here we can see we get the replies. One request timed out and then we get the replies. We will try once more. Just press up arrow, then press enter. And here we can see we get the replies. It's working. Actually, here we ping from PC-A to S1. Even we will try to PC-A to S2 also. Here we can see its IP address, that is 192.168.3.12. Okay, we'll press up arrow and we will change this address to 3.12. We get the replies. It's working. Now we will go to step 2. Complete the following test from PC-B. From the command prompt on PC-B, issue the tracert command to the address of PC-A. What intermediate IP addresses are shown in the results? Okay, we will check that. We will get the IP address of PC-A. IP configuration, we will copy this address. We'll go to PC-B command prompt. Here we will give a tracert to PC-A, and here we can see the details. 192.168.4.1, then we can see 192.168.3.3, and here we can see the intermediate address, that is 192.168.4.1. This is the default gateway for this PC-B. Also, we will ping from PC-B to other devices. We will give a ping. We'll ping to PC-A, and here we can see we get the replies. Now we will try to ping to the switches. It's 3.11, and we are waiting for the replies. Maybe one request timed out. Yes, here we can see it's working. Once more we'll press up arrow and again we will try it, and here we can see we get the replies. Now we will try to ping to 3.12 from PC-B to switch S2. We may get one or two requests timed out due to convergence, and here we can see we get two replies. Once more we will try it, and here we can see we get the replies. Okay, right, that's all in this lab activity, that is configure a router on a stick inter VLAN routing. Now dear friends, if you have any doubt, any suggestions regarding this lab activity, please comment below. Also, if you like our video, give a thumb and share with all your friends. And if you like to contact our team, you can visit our website. Stay tuned, and we will meet again with the next video. Thank you.